All right, everyone. Thank you for joining our LinkedIn live session on auto-generated record keys. Today, I'm here with Siva. Siva, do you want to go ahead and give a quick introduction? And if you're joining, let us know where you're joining from.
Hey, hi folks. Can you hear me, Nadi?
Yeah, you're good.
Okay, cool. We are 8:59. Do you want to wait for a couple of minutes, or you want to get started right away?
Nope, we can get started. We're just going to do a quick intro.
Okay, cool. Hey, hi folks. This is Sivabalan here. I'm one of the PMCs in Apache Hudi. I've been with Hudi for probably 3.5 years now. So I work for OneHouse. My most major contributions are in the open source world with Hudi. I worked on the metadata layer, code transaction layer, record level index, auto record key generation in the recent times.
Oh, okay. Let's see. Sunil says he can't hear us. Let's see.
Okay.
If you're tuning in, let us know if you can hear us. Um, okay, cool. Okay, great. I think there might be a delay with the network. Yeah. Okay, cool. Glad you guys can hear us. All right. Thanks everyone for joining. So we're gonna go ahead and get started. Samil, let us know where you're joining from. Sharissa, great. Thank you, Varun. Glad you're able to hear us. So I'll go ahead and welcome you guys to our event. So I'm Nadine. I'm a Hoodie contributor, and today, we have Siva with us. Recently, we released 0.14.0 that is jam packed with game-changing features for building lake houses. So we have the record level index, we have auto-generated primary keys, we have SQL for incremental pipelines to make it a breeze, just to grab updated records and more. And so today we're gonna deep dive into auto-generated keys. So Siva, thanks for taking time out of your morning today and joining me. So I know primary keys are good for databases to ensure each record in the table are unique,
Mhm.
and primary keys are optimized for data retrieval. But can you explain more on why primary keys are important for data lakehouses?
Okay, cool. So do you see my screen? Uh,
1 second. Um, yes, I think we're good now.
Okay. Let's start with some primer about primary keys. So if you're coming from the database world, I guess this is like 101 of databases. Primary keys, it's essentially it's used to uniquely identify records in like a given data set. So if you take a sample employee data set, employee ID is the typical primary key. If you take like Uber trip data, trip ID is like a unique primary key. The main purpose of primary keys is, in case of, let's say, you're trying to ingest records, you want to differentiate inserts versus updates, so you need to have an indexing or uniquely uh, locate a given record. So these IDs will come into play there. So also on the read queries, also if you're looking to fetch some records pertaining to a given employee ID, it's easier to fetch one record rather than getting like multiple versions of the record and stitching. So this is no different in Lakehouse world too. If you remember, Hudi was invented in Uber to solve the transaction data lake use cases within Uber. So we had a lot of mutable workloads back in Uber as well. So we started with looking at databases, and we realized that okay, primary key has to be there in the data set in order to efficiently support writes and so on. So that's the reason that we started with primary keys in lakehouses, like ensure uniqueness across the entire data set, to differentiate inserts and updates, to ensure there's no duplicates of data on the snapshot queries that you're triggering.
Awesome, thanks, Eva. So can you explain more how primary keys are used in Hoodie and what's the impact to the end user?
Okay, cool. So As I mentioned, on the right path, indexing plays a major role because we want to differentiate between inserts and updates or deletes, whatever it could be. And the user would be interested to see like an aggregated view of a given record. For example, Uber's trip data. For a given trip ID, you want to get like a aggregated view of all the updates happened so far uh, from the given data set. So another major benefit of having a primary key in Hudi is, for example, on the right side, there are a lot of indexes you can build more optimized versions of indexes to increase the latency, even magnitude of orders more. For example, you could have Bloom filter indexes. You could have record level index, which again we recently released in 14.0. These are bound to improve the indexing, or probably from an end user standpoint, the write latencies could see an uptick of, let's say, you could see like probably 40-50% improvement depending on the workloads. So all these are feasible if you have like something like primary keys configured in your table. If you don't have a primary key, you might have to do a entire scan of your table, which is going to be prohibitively very expensive when you're dealing with, like, let's say, petabytes or exabytes of data. Another place where primary keys or record keys come into play in Hudi is during compaction, deduping, log merging. In all these places, Hudi generates a primary key once and then injects into like a meta field. So we keep reusing this record key that Hudi places in the for every record. So it eases a lot of the lookup in most of these code paths within Hudi.
Got it. Thank you. So how do users configure primary keys with the dataset in Hudi? So if the dataset does not contain a primary key column, like let's say for event logs, can they still use Hudi?
Okay. So before I go into the second part, so there are two questions in your question. So first
Yeah.
one is record key configuration. So you could see the config in the slide, which is Hudi data source or write or record key field. That's how you can typically configure like a column. So for example, in case of employee data set, you can set that to employee ID. So along with it, there's another config that people might be aware, users might be aware, who are using Hudi for a long time, which is key generator class. So this is used to specify how the key generation is happening. So in Hudi, a pair of partition path and record key forms like a unique. That's how a record is uniquely identified. So the key generator class will determine how those keys are generated. So the key generator class is meant for two purposes. One is the record key generation, another one is a partition path generation. So from a record key standpoint, which is what the purpose of this entire talk is, there are only two options users have. One is a simple key, which is just one field or a single column. Another one is a complex field, like a multi-field column. So yeah, this is how generally users tend to configure the primary keys for their data sets and Hudi. So let's go to the second question. So this was one of the reasons we started this project. So for the past 2-3 years, we have been supporting Hudi community in the open source. We have come across use cases where some of the data sets or use cases of workloads, like if someone is trying to just dump logs from, let's say, Kafka or somewhere into like a bronze data lake, or let's say some event generation or time series data sets, or some of these use cases are a purely immutable data set. There's no mutability whatsoever for a given data set. So in some of these use cases, the data set does not contain any natural primary key at all. Even if we ask, if let's say it could contain like 100 columns or even 500 columns, but if the data set does not contain a primary key naturally fitting into that use case, so then we are pushing the users to generate a record key like with column, essentially like a generator column, and then they have been using that to set as a primary key within Hudi. So we realized that why do we actually why can't we make it easier for the end user? So why can't we generate internally within Hudi so that the user don't need to worry about generating a record key by themselves? That's how the this project came to exist. Yeah.
Awesome.
So,
Thank you.
okay. So to answer your question, in 14.0, yes, you can generate a data set with Hudi without configuring a primary key by the end user.
And what about the key generator classes? You want to talk a little bit about the different key generators that exist currently?
Okay. So I don't have a slide with that, but I can briefly go over that. So from a key generator class standpoint, we have simple key generator, which is like a one column record key and one column partition path. We have timestamp based key generation where the partition path is like a timestamp, a function of a timestamp. For example, it could be your incoming column could be like an epoch. You can define like a timestamp function, like where you derive like a date string out of it, or you can encode the format of the output of the partition path that you're looking for. So timestamp is another one. And then we have like complex key generator, which is like a multi-field record key and a multi-field partition path configuration. We also have custom key generator where it's a multi-field partition path configuration, but for each of the partition path field, you can encode whether it's simple or like timestamp, for example. So for example, a simple example of complexes, you could define like a user ID. Not user ID is not a good partition path. Let's say date string is one of the field in the partition path, and then let's say there is another dimension column, like a product category that the user wants to partition their entire data set. So there you define that date string colon timestamp, and then you also specify like product category as like a symbol. So you can combine different encoding formats of the partition path in a simple in a single key generator class, that is the custom key generator.
Awesome. Thank you. So,
Okay.
how does Hudi auto generate record keys? What were some of the considerations you had while you were solving this?
Okay. So we had few requirements when we started this. So it has to be globally unique across the entire data set. So it is not just within a single batch. It has to be globally unique across multiple batches. So that's one of the key requirement. And since we are going to internally generate record keys by Hudi, we want to ensure it is highly compressible. Again, there are two um, there's another requirement which goes hand in hand with this. So it has to be efficient to encode and decode. Just because it's highly compressible, we can't give up on the encoding time as well. So another key requirement we had around this auto generation of record keys is resilient to partial task failures. Hudi supports three different engines, so Spark, Flink, and Java. In Spark, you could have partial task failures, and then in the entire Spark DAG, a slice of your task could actually go and re-trigger one of the key generation tasks to be triggered again. So we wanted to ensure our record key generation is resilient to that. It should not result in any data consistency issues if at all such partial task failures happens. And then, yeah, the last one is we wanted to ensure we don't like implement something which is very specific to Spark so that we can't reuse across other engines. Trying to ensure if we can come up with a single piece which we can plug in every engine. So that's the requirements that we had with auto record key generation.
So that's very interesting. Can you go over what the different approaches that you considered for the auto key generation, and how did you, narrow down on this on the final like approach?
Okay, cool. So let's start with this. So I went over the requirements. So we slowly started at least listing what are the options that we have, and slowly we touched base with our requirement and started to scratch one by one. So the first option is if you go to even Oracle databases to see how internally they have like a row ID pseudonym column, which is more like a incremental ID. So we thought, okay, can we do an auto increment? But then, so the issue here is that how do you ensure uniqueness across the entire data set, not within a batch? And then if there are multi-writers, how do you ensure we have like a unique record key generated across multiple writers? So auto increment may not be work in this case. Random ID generation, one of the key requirement that we have is the deterministic key generation even during Spark task failures or task failures in general. So again, we could not go with random ID generation. So if you generate, if you trigger the generation of ID twice, it could result in two different IDs. And yeah, somewhere in the right path in Hudi, we have like we are relying on the hash of the record key that gets generated. So it could result in data consistency issues. The third one is monotonically increasing ID. If you work in the Spark world, you could there is a function that you can use from the Spark, which is monotonically increasing ID. Again, we there are two requirements which do not fit in our requirements, which is we don't want to pick a implementation which is very specific to Spark. Another one is this is also does not meet the requirement of the Spark task failures. So if there is a uh, partial failure, and then if the Spark DAG is re-triggered, this monotonically increasing ID might result in data consistency issues. In fact, around the same time when we were actually devising this auto generation within Hudi, we got to know someone from the open source actually were using monotonically increasing ID, and they reached out to us that very occasionally during Spark failures, they are hitting some issues. Can we help with the use case? So after going through all this, we realized that okay, why can't we latch onto something which is uniquely identifying single batch, and then within that batch, can we ensure if we can generate like a unique identifier, then it'll solve the global uniqueness problem. So our commit time is unique for a given batch, and then it's globally unique across the entire table as well. So we came up with this format where we have the commit time or the instant time, and then the partition ID or the task ID is a slice of the data within the entire batch. And then within that batch, we can add like a row ID, a sequentially incrementing identifier. So these are the three components which we narrowed down, which will produce like a deterministic key. So with these in mind, we came up with 3 to 4 options that we can potentially go with. The first option is just the original string as is, without changing anything, no special encoding or anything. Then UID 6 and 7. So this did not have these three components in it, but we are interested to see whether it could actually produce more compressible format. Is there something we can, if at all, it could produce us like a compressible key? Can we do something about it? Next one is base 64 encoding. So we took, so instant time is a commit time. So we took the lowest 5 bytes from the base 60 from the commit time, and then the partition ID, we took the lowest 3 bytes from the partition ID. It could support like probably 4 million number of partitions, and we took lowest 5 bytes from the row ID, which could support like 1 trillion number of records. So again, all these are within one commit time, one batch of ingest we are talking about. So we took a base 64 encoding of that, and then we devised like a record key out of it. And the last option is ASCII, which is similar to base 64, but after we got the bytes generated, we encoded in the ASCII instead of base 64. So these are the 4 options that we considered. So here you could see, so we did a benchmarking, micro benchmarking, to see how it stands with respect to the sizes that you could see. So we generated probably somewhere around like 100 meg Parquet file with like probably somewhere around 1 million records or something, if I'm not wrong. So and found the size of these. So as you could see here, so on the third or fourth column, you could see the compression ratio. Um, so UID 6 and 7 is highly compressible, um, whereas base64 and ASCII are not as compressible as the UID 64. But an interesting thing to note here is that if you look at, let's say, the third column here, so let's take a baseline. Baseline is nothing but the original key as is. So the size of it is somewhere around 244 KB. So the UID is like 6x larger compared to the original or our baseline. So we disregard UID6. It is not, probably you can just go with the original key itself in that case. Base64 and ASCII are actually way better. It is probably clocking somewhere around 70 to 80% or compared to the baseline. So it is definitely a good candidate to consider for our purpose. And then, as I mentioned, another requirement that we had is, yeah, okay, it is highly compressible. Okay, but how much time does it take to actually encode or generate these record keys? So we started measuring the latencies to generate these record keys. As you could see here, yeah, two of our potential competitors was base64 and ASCII, but the time it takes to generate that is huge. It was pretty much like 400x. So it's very clear that we can't go with the base64 and ASCII just because it's highly compressible. It doesn't fit our the other contenting requirement of the runtime to encode. So we just went with the original record key format, which is instant time suffixed with partition ID, suffixed with like a sequential incrementing ID within that particular slice of data or Spark task, you might as well call. So that's our yeah, that's how we narrowed down our uh, the approach to auto generation of record keys within Hudi.
Thanks. That was really eye-opening. Samil has a question. He asked, can users customize the auto key generation process in Hudi? And if so, what are the options, available options?
So okay, so here's our see. If at all you want to, so I'm trying to understand why would someone try to change the auto record key generation, because if they have their own ways of generating record keys, a user can actually generate it before ingesting to Hudi and then set that particular, let's say they can add a new column, generate that mm, uh, record key by themselves, and then set that one as the primary key when they are ingesting to Hudi. So they don't need to come and implement their own auto record key generation, or key generation itself is an interface. So they can extend the key generation interface, give their own record key generation, fit in their own record key algorithm in there. So this auto record key generation is more like if you go to Oracle, there are primary key tables, but you can generate a table without a primary key. So going back to the initial slides that we were talking, that could be data sets which is completely immutable. The user does not care. I don't want any primary keys in my. I do not know how to configure one, or it's just log dump. All I want is I just want the data from source A to Hudi. That's it. So we are just trying to ease the usability of those scenarios. But if they have a specific requirement in the way how the record key is generated, yeah, you can extend a record key generation, define your own record keys partition path. So I don't see why this auto generation of record keys should be exposed to the end user. Does that answer someone's question?
I think he said it did. He had another question, but I think you kind of touched on this a little bit. He asked, how can users monitor the performance and effectiveness of auto key generation in their Hudi deployments? You kind of touched this a little bit with the compression and the time to generate them, but not sure if you have more to add here.
Yeah, this is one of the exercises that we did to I mean, if they have an existing data set, they can try to compare with enable auto generation of record keys and see how it compares. Uh, but apart from that, how else we can validate the record key generation? But yeah, we showed the micro benchmarking, right? According to our micro benchmark, to um, the average time to generate this is like like 0.0001 millisecond, which should be pretty much in like a petabyte scale. I don't see it should be an issue, performance issue. Um,
Awesome. Thanks, Emil, for your questions. And if you guys have more questions, definitely type them in the comment box. So, are the record key generations resistant to task failures, Siva?
Oh yeah, we did briefly touch upon that.
Yeah.
I don't have a slide, but yeah, I can explain. So, yeah, if you see the skeleton of the entire write of like a single write to a hoodie, um, uh, to assist with file sizing, bin packing, routing slicing the data into like properly sized files. Um, Hudi does rely on hashing of the record keys in that flow. So for that, the record key generation or the auto record key generation has to be resilient to task failures. In rarest of occasions, if the entire DAG is re-triggered for a slice of data, you could see some data consistency issues. So when we came up with this um, support for auto record key generation, actually we actually went through like a failure injection framework to actually simulate failures, and we ran like a test frame. We ran like a data set of like which was ingesting probably like 2 to 3 days continuously with random failures injected along the way with Spark task failures, and ensure that there are no data consistency issues seen. Yeah.
You also touched on this a little bit, but if Hudi has auto-generated keys, why do we have to use the key generator for data sets that support the primary key columns?
Okay, that's a good point. So let's go back to this, let's say, employee data set.
Yeah.
Um, so we are trying to ease the use of Hudi for immutable use cases. But if you have a valid mutable data set, so employee data set, in that case, employee ID is like how that's how you uniquely identify a record. Already you have, let's say in 13.0, you have configured employee ID as your record key. In 14.0, I guess your question is why can't I let Hudi generate unique key? So, see, Hudi does not know anything about the business use case of the data set that you're storing. This is like a very generic framework which will help you generate some unique keys for every record. So, in this case, if you're ingesting uh, employee ID 1 in commit 1, and then if you're ingesting another version of the updated record in commit 2, what ideally the user wants is they want to update the same version of the record. But if you end up using auto generation of record keys, it could generate a new record key for that new version of the record that you are ingesting to Hudi. So users should be aware of when to use this auto generation of record keys. It's mostly for immutable use cases, or the dataset does not have a natural primary key in it. Um, if not, you might miss updates. You might see duplicates on your query side.
Thanks, Eva. That's awesome. So I have a couple last questions. So how do you begin configuring and enabling auto key generation on record keys? You had some code snippets earlier. Is that the same
Yeah.
one? Yeah.
Yeah. So all you need to do is do not set any value for this record key field. That's it. The Huri.data source.write.record key.feed. Until 13.0, there's a mandatory field. If you don't set it, your writes will fail right away. With 14.0, if you're not setting any value for this config, Huri will automatically generate record keys for you. It's as simple as that.
Awesome. And so, if anyone is interested in contributing to the Hudi project, what are some of the great ways they can get started? And I'll share the contribution list in the chat too.
Oh yeah. So yeah, we have it in our website. So we have a separate link for like yeah, people who are looking to contribute for the first time. We have a dev setup and like properly written some helping guide to for someone to get started. We also have tagged certain Jiras with newbies, so that anyone who's looking to get started, they have something to start upon. We can try to put together more information if that would be helpful. But they can reach out to any of the committers or PMCs out there if they're running into any issues. We'd be happy to help on the contribution end.
Awesome. So I shared the contribution, how to contribute, and I also shared our Slack community as well. If you have
Okay.
more questions about auto-generated keys or how to contribute to the Hudi project, whether you want to work on building sample code or tutorials, I know Samil does that a lot and he's joining us today, or you want to do code contribution, join the Slack community and we'll all be happy to help you on getting started on your journey. Or if you just question about how to use Hudi as your data lakehouse solution, those are also all great questions as well. If you look on the Hudi LinkedIn page under events, there was also previously we had a Notion LinkedIn live session where Notion shared their journey and it showed how they are using Hudi for their data lakehouse solution. So feel free to check out that, and I can link that LinkedIn live as well in the comments down below, or you can just check out the LinkedIn page and you'll find it, the Hudi LinkedIn page. So if you have any questions, I can give you a few more minutes to type them in the comment box. But otherwise, we want to thank you for joining us today and stay tuned for more live sessions with all of us on the Hudi community.
Okay, cool. Thanks a lot, guys. Hope you guys got to learn something about
Yep.
Hudi this time.
And feel free to join the Slack if you have more questions or follow up on the comments down below and we'll answer them.
Okay,
Great.
so
See you, everyone. Thanks. Bye.